Okay, continuing with section 1.2, we are now going to look at examples. So the first example here is this function given as x is equal to cosine 2t a solution to the differential equation which is given over here. So let me rewrite the equation. It says dx by dt plus tx is equal to sine of 2t. So we note that the independent variable is t and the dependent variable is x. So that's why our solution is written as x is equal to, I shouldn't say solution because we don't know yet if it is a solution or not. But the given function is x is equal to cosine t. So I start with the function and I will differentiate it, because you see in the differential equation, so one place we have to enter the function here, and here we have to enter the derivative. So we need to differentiate the function. So this gives me dx by dt is equal to, okay, just hold on. So I get minus 2 sine of 2t. Okay. So this is the derivative. Now what do? We just plug in the differential equation. So if we have to plug in things on the left, we do that, and if we have to do it on the right, we do that. But in this case, you can see that we have to plug in only the left. The right hand side is what it is. So when I plug in the dE, so dx by dt is okay plus tx. So t is just t, x will be cosine of 2t. And on the right hand side, I have sine of 2t, whatever is on the right side of the differential equation here. Now I look at the two sides. If I have to simplify, I will do the simplification, but you can see I cannot simplify much here. And the left hand side doesn't look like the right hand side, so we say no, it is not a solution. Okay, looking at the next one, now here it's saying show that. So it's not saying determine whether it is a solution or not. It's saying show that this is a solution, which means this function is a solution. So my dE is x square d2y by dx2 is equal to 2y. So very simple equation, and our phi of x is x square minus x to the negative 1. So I am going to call it y. So because we have in this is a second order differential equation, so we have to find the first derivative and then the second derivative. If you recall, yesterday we found the derivative of this. Now when we are doing the derivatives, it's our choice. You don't have to do dy by dx, you can write y prime. it will be, so derivative of x square, which is 2x, minus derivative of x to the negative 1, which is negative 1 over x square. Or if you want to do the whole steps, so minus, applying the power rule of this term, second term, this one. So I have negative 1 times x to the negative 2, which gives me 2x plus x to the negative 2. Now I write this way because it's easier to do the derivative when it is in this form. But I will simplify for the answer, final answer, plus 1 over x square. Okay, now we do the second derivative. So y double prime is equal to, so I am going to look at this, remember that's what I said, I am going to look at and differentiate it. So it gives me 2 from the first term plus negative 2 x to the minus 3. Okay, so which means is equal to 2 minus 2 over x cubed. Okay, now I have the second derivative. Now we go back, plug it in the equation. Okay, so x square times the second derivative which we just found, this one, 2 minus 2 over x cubed, equals 2y. So 2 and the y. What is y? Remember it was x square minus 1, x to the negative 1, or x square minus 1 over x. Now I will simplify the left hand side and simplify the right hand side and see if they are looking the same. So let's distribute. That's all we can do. Now notice here, this second term is down here, we have x cubed. So when I multiply it by x square, this second term, so I get 2 over x. And on the right hand side, distribute the 2. So same. So yes, we have proved that this is a solution. What about the intervals? On what interval is this solution? So for the interval, look at our solution. So our solution is x square plus, oh sorry, it was minus, x square minus 1 over x. So you see, this second term says that we cannot have a 0. So the domain of phi is minus infinity to 0, union 0 to infinity. So basically this is our solution is on both these intervals. So it can be, it cannot be at the same time on both intervals, because if it has to cross the vertical asymptote, which functions cannot do. But it could be that under some for some initial condition, it will be in the left interval, and for the other it could be in the right interval. But if the question says, show that this is a solution on 0 of infinity, so yeah, that is true. It is a solution on 0 infinity. And if it says it is a solution on minus infinity to 0, that is also correct. So separately they are correct, and then combined also they are correct. looking at the next one. So this is saying show that y2 plus x minus 3 is equal to 0 is an implicit solution to the differential equation on the interval negative infinity to 3. Okay, they gave us the interval, but we have to verify it. Okay. So now, if you notice here, this solution is not, well, I can write it in the explicit form, right? So if I try doing that, it will actually be longer. So you can do this. Why? Because your solution is given in this form. So we can say y square is equal to 3 minus x. So y will be equal to now we can check each one. So let's first check this one. So the equation, okay, it says first order of the equation, so not too bad. So the equation is dy by dx equals negative 1 over 2y. Okay. So I have this y is equal to this. So what will be dy by dx? 1 over 2, 3 minus x raised to negative 1/2 times negative 1, which can be written as negative 1 over 2 into square root of 3 minus x. But what is square root of 3 minus x? That is y. So you can write this as negative 1 over 2y. So you see we are getting the differential equation that we have here. So it means that this is a solution. Okay. Now check the other part. The negative 3 minus x. So now doing the same thing, dy by dx, negative 1/2 3 minus x to the negative 1/2 times negative 1. Okay, now I will not multiply the two negatives here, because I know that one negative I need here and one negative I need for the differential equation. So I am going to rewrite it like negative and then negative 1 over 2 3 minus x. Now this negative, I can put it in front of the square root 3 minus x. So I have negative of 1 over 2 into negative 1 into 3 minus x. But this is what? This is our y. So we get negative 1 over 2y. So again, so this is the solution. What about the interval? For the interval, we notice that from here or from these two equations that we must have 3 minus x is greater than 0. What does that mean? 3 is greater than x, or x is less than 3. Well, what is that? That is giving us the interval negative infinity to 3. So we say this is the solution on the interval negative infinity to 3. Okay, I will stop here because the next examples are a little bit different. So in another video.